probably went over this at the end of algebra, and maybe you could have like some decimal answers. For this section, all of our solutions, they are going to be exact and simplified. So you won't have any decimals. You could have whole numbers, but if you have a radical that's not a perfect square, you'll simplify it just like we have been doing. And we are going to solve equations, and some of them could have imaginary answers. So if you did this previously, you didn't have imaginary answers, but now we know how to use those, so those are going to be a possibility. So we're going to solve quadratic equations using the formula, and then we are also going to classify roots using what is called the discriminant. Okay, so those are going to be our two main focuses today. Okay, so for the quadratic formula, you are going to use this when your equation is in standard form. So we have the ax squared plus bx plus c equals 0. So once it's in standard form, you can pick out your a, your b, and your c. We are going to substitute those into the equation, and then we are going to practice simplifying those together. Alright, so I want you to read the directions for the first problem. Notice it says that we're finding what? Yeah, we're finding the zeros, so that's something that we've been working on. Finding the zeros, we've graphed, we've used completing the square, we've done factoring, and now we're also going to have the quadratic formula. Okay, so I'm going to give you your f of x. We'll do the first one together kind of step by step, and then I'll give you some time to try these on your own as well. And when I do the quadratic formula, I do like to write certain things out. I feel like that makes it a little easier for me to double check that I'm simplifying everything correctly. Okay, so we are finding the zeros. We do have to use this formula, and I'm going to give you your first function. So your first function is f of x equals 2x squared minus 16x plus 27. Alright, so using standard form, our a value is going to be 2. Our b value has to be negative 16, so you're taking that with it. And your c value is 27. So we're going to go ahead and we're going to plug those into the formula. So this is x equals the opposite of b. So if it's negative 16, thanks, plus or minus the square root. And for this one, I am going to just show you it's negative 16 squared minus 4ac. And then as we go along, I'll tell you how I shorten that up a bit. Okay, and then on the bottom, it's 2a, so 2 times 2. So generally when I do this, I'll square the 16. So 16 times 16. Remember, that should always be positive whenever you square something. And then these, I can multiply together. But you do have to pay attention to the signs. So this is negative 4 times 2, which is negative 8. Negative 8 times 27, you can do that in your calculator. You'll get 216. But you do want to pay attention to the signs, because if your a value is negative, right, then when you multiply a negative by a negative, what does that turn into? A positive. So this won't always be a minus. Okay, it just depends on whatever your signs are. And then 2 times 2 is going to be 4. Okay, so then I subtract 16 plus or minus root 40 divided by 4. Okay, and then, Jack, what are you thinking? How should I simplify? How can I simplify the square root here? Well, you can't. We are going to divide, but first let's simplify this radical. Okay, so how can I simplify that? Okay, yeah. Well, it has to be a perfect square though. So what's going to be the perfect square factor? Mm-hmm. Yep, because this is just like, and you can do this with, you can do this when you are multiplying. So root 4 times root 10 becomes 2 root 10 divided by 4. Okay, and then once you get here, now we're going to separate these into 2 terms. Okay, so now is where we simplify. So this is 16 over 4 plus or minus 2 root 10 over 4. Okay, so when I say simplify, you're really just reducing the fractions or you're performing the division. So 16 divided by 4 is going to be 4. And then for 2 and 4, remember, that reduces, 2 over 4 reduces to 1 over 2. But I don't want to write 1 root 10. 1 times root 10 is just what? 1 times anything is just itself. Yeah, so this is just root 10 over 2. And that is my final answer. Okay, I'm just going to show you another way too. So, if you are just simplifying the 2 root 10 over 4, right, it is like 2 divided by 4. This would be a 1. 2 goes into itself 1 time. 2 goes into 4 twice. 1 times root 10 is root 10. That's how I'm getting the root 10 over 2. I know some of you like to think of it as, oh, 2 over 4 is 1/2. So this is 1/2 times root 10. But this wouldn't be completely simplified, okay? You have to multiply those together. So if you're multiplying a whole number by a fraction, remember how we put 1 underneath and we multiply that across the top and then across the bottom? That's why this is root 10 over 2. Now, why can't I simplify that to root 5? You guys remember? So that's why you aren't going to break this down any further. But, like, why can't I do the 10 divided by 2 here? What's stopping you from doing that? Yeah, great, you know. Right. So if it's in the radical, it can only be simplified with other things in a radical. Okay? And 2 is not inside the radical, so I can't. Okay? If 10 was not inside, yeah, I could simplify. If 2 was inside a radical, then I could simplify. But because 1 is inside the radical and 1 is outside, that is not allowed. Okay? Mm-hmm.
For that problem, why couldn't you have put like 4 divided by, or 16 divided by 4, which would be 4, and then put 40 over 4 and then taking the square root of 4 to get like...
Well, you could. You mean like divide first and then simplify second?
Yeah.
Yeah, you could. Like, you could leave it, but then you can't divide root 40 by 4 because that's inside the radical and this is outside.
Oh.
But if you wanted to, like, leave this as root 40 and then simplify here, that would be fine.
Okay.
All right, so let's try B. I'm going to let you guys plug this in so you can see what works for you. Okay, and I want you to give that one a try. Alright, so the first thing is I like to identify what my A, my B, and my C are so I know what I'm going to plug in, okay? So, Dan, what's my A, B, and C for this?
A is 4.
Yeah? Okay. Good. Alright, so now I'm going to plug them in. So I have x equals, okay, and then Ashley, will you tell me what you put? So x,
X equals negative 3 plus or minus square root of 3 squared minus 4 times 4 times 3.
good. And all of that is over what?
2 times 4.
Great. Okay, and then, yeah,
Are you guys supposed to be the negative 3 is under the square root?
Nope, so it's just a b squared underneath here, and this is the opposite. So the opposite of b would be negative 3, and then this is b squared, so it'll just be 3 squared. Now, really, you are going to square it, so that shouldn't mess up your final answer. So it'd be negative 3 plus or minus. And sometimes I actually just start here, like with the 9. So 3 squared, that's something we can do in our head. But then I always like to write out this part so I can make sure that my signs are correct. So this is a negative times a positive, which is going to be negative, and then a negative times a positive, which again will be negative. So this should be minus 32. Okay? And then how did you guys go about this next step?
I just simplified both and the square root.
Okay, and then what'd you get?
Negative 23.
Good. Okay, so in my last class, some people try to split this apart, and you don't want to do that. Okay, so you can't do the square root of 9 minus the square root of 32. That's not going to be the same. So I always like to show why that doesn't work. If you have the square root of 16 plus 9, if you were to split that up, it would be the square root of 16 plus the square root of 9, right? So this would be 4 plus 3, which is 7. But if you do 16 plus 9, I know that that's the square root of 25. And what's the square root of 25? 5. So are those equal? No. So this is not allowed. You can't do that. This only works if you have multiplication. So if this was times 16 times 9, I could do root 16 multiplied by root 9. 4 times 3, which is 12. And then let's check it. What's 16 times 9? If you multiply, you should get 144. What's the square root of 144? 12. Okay, so these are the same. So when you multiply, yes, you can split it up, but if you're adding or subtracting, you cannot. Now you have that negative underneath, right? So Gwen, what do we do when we have a negative underneath the square root? What has to come out? Yeah, we have to, now we're going to use our I. So this should be negative 3 plus or minus I root 23, because this is like the square root of negative 1. Okay, divided by 8. And then our last step is we're just dividing both of those by 8, and then we'll simplify if we need to. Okay, so negative 3 over 8 isn't going to simplify. I have nothing to simplify on the outside here for this time. There's no perfect squares in root 23, so I'm just going to leave it. Okay, you could also put the I like on the side here. Just make sure you don't put it under the radical or in the denominator. Those mean different things. Okay, questions for me on part B? All right, let's try another one. All right, so you have g of x equals x squared minus 8x plus 10. Okay, so I want to see if you guys can simplify that all the way to the end. Alright, so far so good. You guys with me on the first step? 8 plus or minus root 64 minus 4 times 1 times 10. Okay, so 4 times 10 is going to be 40. So when we subtract 64 minus 40 is going to leave you with what? 24. Okay, so I'm fine if you just go here. Okay, divided by 2. Now, with radicals, we have to find the perfect squares. So, Seth, how am I going to simplify the square root of 24?
4 times 6 is 24.
Good. So if I simplify this, root 4 times root 6, what is that going to become?
2 root 6.
Yep. And do you guys see what I do so I don't have to like write the whole thing out again? I can just like show my work like, oh, this is root 4, root 6, this is how I got here. And then from there, you're dividing both of these by 2. Okay, so if there's 2 terms divided by 2, you're going to apply it to both of them. Okay, so Luke, what did we get for our final answer?
You get 4 plus or minus square root of 6.
Yep, 4 plus or minus square root of 6. So because you have 2's on the outside, those do divide to make 1, so you're just left with root 6. Okay, how'd that go? Doing good? All right. Now, I do want to show you another type that you might see. You don't have to write this down with me. I really just want you to pay attention. So sometimes this might be a perfect square. So let's say instead of 24, we have the square root of 36, okay? So the square root of 36 is going to simplify to what? 6. So this is 8 plus or minus 6 divided by 2. So when you're doing this, you can actually simplify. You can do 8 plus 6 divided by 2. What's 8 plus 6? 14. So 14 divided by 2 is going to be 7. And then we would do 8 minus 6 divided by 2. So 8 minus 6 is 2. 2 divided by 2 is 1. So your final answer would be x equals 1 or 7. Okay? So those would be your 2 answers. Or I think if when you check with the key, it'll be like 1 comma 7. Those will be your 2 answers. Remember that we do have 2 answers here. We have 4 plus root 6 and 4 minus root 6. So you do have 2 different solutions there. But you can just connect them with the plus or minus. All right, questions for me on that? All right, let's talk about something called the discriminant. Have any of you heard that term before? It's okay if you haven't. We're gonna learn about it today. So if it's your first time hearing it, that's fine. The discriminant is actually just a part of your square root, the square root in your quadratic formula. So we can use the discriminant, which is b squared minus 4ac. Okay, so that's the part under the radical. Okay, so we can find that part under the radical to find the number and type of solutions that a quadratic equation has. So there's 3 different types. If the discriminant is positive, that means when you do b squared minus 4ac, you would get a value that's greater than 0. What happens is you would get 2 distinct real solutions. And you can use the symbol for real. And when they use the word distinct, what they mean is that they're not the same. So they're 2 different real solutions. So let's think about how that looks on a graph. If you have 2 real solutions, what are we going to see on the graph? We talked about this last week. Because remember, the solutions are zeros, and the zeros are what on the graph? The what? The x-intercepts, right? So if there are 2 real solutions, then you should see 2 x-intercepts, right? We have a parabola And then you should see 2 unique x-intercepts, okay, on your graph. Okay, in some cases, you might have that the discriminant is equal to 0. Okay, and so let's play pretend again. Let's say instead of square root of 36, let's say that this was 0. Well, what's the square root of 0? 0. So if I had 8 plus 0 and 8 minus 0, wouldn't both of those cases lead to just 8? Okay, so then I'd have 8 divided by 2, and that would only leave me with 1 solution. Okay, it would be real. The only time you're going to have imaginary is when you have what underneath the radical? When do you have imaginary? Yeah, if there's a negative under the radical. Good. So if there's a 0 underneath, there's just one real solution. Do any of you remember what that looks like on the graph? There's one real one. Yeah.
This is just a guess, but could it be like the tip of the parabola is touching the x-intercept?
Yes. So the vertex of the parabola, that just touches the x-axis at one place. So it could look something like this, where there's only one intersection point. So one intersection with the x-axis. And of course that intersection is going to occur with the vertex. So then we're left with our last case, which is when this value is a negative value. Okay, so when that value is less than 0, and this is going to produce imaginary solutions, and again, there will be 2 of them. There's 2 of them because you have that plus or minus. Again, these are distinct, so 2 distinct imaginary solutions. And then there are also some other names for imaginary solutions that you can use, okay? Just like, you know, how we can say, hey, hi, hello. There are different ways that you can say imaginary. So another way you might see this is complex, non-real solutions. So again, when you are checking your homework, you can say imaginary, that's fine. It's just the key might say there are 2 complex, non-real solutions. I'm perfectly fine with you saying imaginary. So just know that those are interchangeable. Okay? Okay. So for example 2, it says find the type and number of solutions for each equation. And that's exactly what the directions are going to say when you are doing your homework. But in order to find the type and number of solutions for each equation, we are going to find the discriminant. And that is something that you'll have to do on your next test. So make sure that you are finding the discriminant and identifying that value. So finding the discriminant just means that you are using the b squared minus 4ac. Now, when you are finding your values for b and a and c, let's also keep in mind you have to have your equation in standard form. So you have to have it in the form ax squared plus bx plus c. And then that should be equal to 0. So as I look at part A, I can see this isn't equal to 0 yet. So I'm just going to move over my 12x have to use subtraction. And then when I write this out, I write it in standard form. X squared minus 12x plus 36 equals 0. And then from there, I can identify my A, my B, my C. Now, if you don't see a number in front of x squared, that means the value is equal to 1. Okay? If there was like no term, like let's say there was no C value, that's when you would say 0. Okay? So this is going to be 1. B is going to be negative 12. C is going to be 36. And then I want you to find the discriminant. So find the b squared minus 4ac. Alright, so you should have negative 12 squared minus 4 times 1 times 36. And again, you do want to just pay attention to the signs because if this is negative, okay, if one of these is negative, this will turn into a plus. Okay, and then this, you should have got 144 minus 144, so your discriminant is 0. This is your discriminant. And then I just separate this with a semicolon. So if it's 0, we can just use our chart up here, right? If it's equal to 0, we have one real solution. Okay, and then go ahead and go ahead and do part B and C, okay? Also, as a side note, for the discriminant, you only have to do the b squared minus 4ac. You don't have to do the entire quadratic formula, okay? I've been noticing is, one, make sure, like, if it's positive or negative, you're identifying the type of solutions, okay? So don't just tell me that it's negative. Identify how many solutions they are and what type, okay? So for B, you should have got negative 16, okay? And then it's two distinct imaginary solutions, or you could also say two distinct non-real complex solutions. Again, either one of these is fine. Okay, any questions for me on part B? Okay, I came around and it looks like you guys did a pretty good job of that. All right, and then for C, you should have got positive 24. So what you're writing is the discriminant and then the number and type of solutions. So there are two solutions, they're distinct and they are real. Okay, so that's the type. And then the number would be 2. Okay? Alright, we are going to start submitting our homework in a different way. I'm hoping this is going to provide like better feedback for me and for you. And this is going to be helpful because now I'm going to have a record of it. So as I'm communicating with your parents and as you and I are trying to figure out like what you need to work on and what we need to prepare for when it comes to tests and quizzes, I think it's going to be really helpful for you to be checking your homework as you go along. So I'm going to show you how this is going to look in Google Classroom. So we are going to be submitting the homework in Google Classroom. You'll be taking a picture of it, and it will be due at midnight the day that it is assigned, and 4 points. And if you only do part of it, that is fine too. You can still submit that. That way I can see what you are doing. And then I'm also going to post that with the key so that you can check as you go along. Okay, so I'm going to show you how this is going to look. I'm actually going to post this right now in your class so you can see it. Okay, so in your Google Classroom, it's going to be here. You have the 2.6 homework, and it just says take clear pictures of your homework, work must be shown, problems corrected for full credit. So I'm going to leave the correcting up to you. Like I know some of you like to like star when you get it right, or circle the ones that you get wrong. That is perfectly fine. If you want to put like plus however many you got right at the top, that would be really helpful. If you could correct it in pen, that would be really helpful. I know some of you will kind of correct it as you go along, so if you want to put like a star or like a note by the ones that you got incorrect so I can see like the mistakes that you made, that would be great. Okay, and then you're just going to take a picture, you're going to submit it. If you want it for points, then you just have to get it in before midnight tonight. And then I know with some of you, if like you have really busy schedules and you know it's a challenge for you to get all of it done, make sure that you're picking some of each problem. I think sometimes students think like, oh, if I'm not going to get points if I don't do the whole thing, then why am I going to do it? Well, you are ending up losing points. It just shows up on your tests and quizzes and not on the homework. Okay, and most of your grade is based on the test or quizzes, which is why we got to make sure we're getting our practice in. You're still going to have the calendar, so you can still find your assignments there. I'm going to give you time to start your homework today. And then I did just write a little reminder for you. Make sure you submit your homework on Google Classroom. Check it with the key. Okay, so that's what we will have for this week.